Welcome back, Generals, to another Let's Fix Generals 0 Hour to make the best game ever. We are still developing unassemblize tool. Good, so last video we have made some decent progress. It already shows us some stuff here in the assembler view. And yeah, we basically now need to put this stuff here into this side as well, right? Yeah. Jump. Let me see. So ASM printer, append assembler, instruction. If ASM len is bigger than 0, can assembler len be 0? What? Ah, I see, I see. It's specific to this code. Okay. Unrecognized opcode. Assign unrecognized instruction. Unrecognized instruction. To string. ASM printer to string. Append white space. Indent len. Append strip. Strip quote. Oh, right. So this one still shows a quote in here. Right. So we need to have a toString function. Indent len. Recognized opcode. I would say we make a custom function for our purposes. So So MQI app. Let's call it toString. Instruction indentln is valid. Bytes s. Unrecognized opcode. Let's go without the indentln. Append white space. Or we make append white space in place, move it to util. Append white space. Okay, let's remove this. Thyme. Is jump. Thyme. Okay, let's put a static here, toString, instruction. And we take it and move it above the button. Well, yeah. toString. there a feature in ImGUI to change the font color in texts? Yes. Push style text. Yeah. I think we should do this differently. Strip. Ah, shit, we need to strip. Ah, shit. This is bad because it means we always need to allocate. Well, we can also have a buffer. Yeah. No, we can't because of this. Oh. I think we should do it differently. Let's copy this logic here. And we go to here, assembler. So we say if instruction is invalid, then what the hell? Let's comment this. Instruction. Okay. So if instruction is invalid, then we do ImGUI text. Unrecognized. Opcode address 0% bytes %s, right? Actually, we can just say unrecognized opcode because the address and the bytes, they're already on the in other columns, so we just say unrecognized opcode. Yeah. To text unformatted. Okay, then we don't need to allocate anything. Okay. Then otherwise, if it is a valid one, then we do. Okay, here it gets tricky because we need to strip the spaces away, so that's bad. So it means we do need to make a copy of the string. Yeah. If it has quotes. Yeah. Huh. ASM instruction. Oops. ASM instruction. We don't have any information if it contains a symbol name. Can we know this? Poof. Don't think so. the easiest way. It's a bit of a shame that we need to process that. Yeah. Instruction buffer. It's also quite expensive this year. Every time it's an allocation here. Yeah. Or is it not? There's a format to function. Output IT. So you can give it a buffer. That's not bad. That's not bad. Can we give it also a max size? Format 2. No. Get iterate. Out. Get buffer. Show. Buff. FMT lib format 2. format 2. I would like to see an example of format2 function, because if it works the way I picture it, it does, then I think we should switch to this function. Because this one has a disadvantage. It always has to allocate here a new string. Now, if this string is really short, like in this case, then there's small string optimization, there's no allocation. But typically we have longer strings, which would then allocate. So we cannot bank on this. Sample. Jesus. Okay, let's ask ChatGPT. Can you give an example how to use FNT format2 function? It's kind of bad that they don't give samples on the GitHub page straight away. Easy to see. Format. Powerful future. Okay, let's see. So we have string, result, read size, allocate enough space for formatting. Well, but resize is the wrong call for this. Or is it not? Why resize? Trim the string. So you don't, it's not a pushback. Okay. Okay, so I see. You allocate enough space first. So resize does allocate the space. You can write into it. Okay. And then you shrink it afterward. Trim the string to fit the actual output. Yeah. Yeah, I think we should definitely use this wherever we have a lot of formatting in a loop. Yeah, so we basically put a buffer string somewhere, or vector for that matter, string, vector, doesn't matter. And then, yeah, format. But what happens if the format2 requires more space than the hundreds? What then? Like, this looks fishy. Points to the end. Buffer must be pre-allocated with enough space. Yeah, but how do you know enough space? Back inserter, aha. Reserve space. Yes, that's better. Then we give the back inserter. Yeah, exactly. This is what I would have pictured. Yeah. And I think we can do the same with string. All right. See, style string by adding a null terminator at the end. Format to n. Aha, you can also give it an end. Can we also use back inserter? Back inserter with std string for fmt format. fmt format. What was it? 2. Yes, back inserter incarnation. Results, initial content, back inserter. Aha, okay. So we would reserve the string and then clear it before we format it, then give back inserter, and then it inserts in there. Okay. Mm-hmm. Format 2. SD back inserter performance. Very inefficient. Override for every element when you're copying. Checking size, yeah. The problem that I see with back inserter is that we avoid the allocation, but this thing, it always Like there's overhead with the back inserter because it just adds one element at a time. And a back inserter needs to check if there is enough capacity left, right? So, and then when it adds a new element, so one character, it then needs to increment the size. So the back inserter, I don't know. Can the back inserter back inserter? STD back inserter doesn't exist. What? Oh, Jesus. It's hard for me to anticipate whether a string allocation or back inserter on an existing string will be faster. It's not clear to me like what overhead the back inserter has. If can it work in a way where you say back inserter, we insert n elements into the back inserter in one swoop? I don't know if that works, or if you really have to go one by one by one by one. This is unclear to me. Implementation. I would like to see a back inserter. Well, I would like to see some, I don't know, performance. SED back performance inserter versus allocation. Performance comparison for different ways. Okay, quick bench. Let's see what this does. Okay, the quick bench is loading very slowly. Slow bench. Oh, okay, it had to execute it first. Okay, so what do we have here? We have... Oh, I didn't know that there's such a website where you can do benchmarks. Oh, that's cool. So we have, what do we have here? There's a vector with some integers, resize. Okay, so it just populates this vector. Okay. Then in a lambda, so this is global space. Okay. And then here we have a function for auto underscore state vector destination resize, and then copy elements. Mem copy. Let's see. CPU time 1 times faster. What? Okay, so func3 vector dst vec resize m. back inserter. Copy back inserter DST, which is by far the slowest. Aha. Okay. Yeah, that's what I fear, that the back inserter itself will be quite expensive to copy with. Yeah. So the most efficient probably will be here. I expect the most efficient will be we do a resize of the string, and then we format it to n with a size limit so that we don't write over the buffer size. And then, yeah, that's it then. And then we resize it to like the max length that we get with the IT. Yeah. So basically we try to supply a string that certainly is long enough, but there is a cap. And if the cap is hit, then yeah, bad luck. But like we do get the performance benefit then, because here, basically with the format 2, we just give it like a buffer. Like here you can write to this. You can write to this in the most efficient way. If you give it the back inserter, it's not the most efficient way. So it's probably not what we want. So is there a helper function format to n with string? That would be useful. Let me see. Format to n. Here. So there is iterator. Huh. Okay, that's strange. Enable if output iterator. Okay. Let's ask ChatGPT. Can you write a wrapper function for FMT formats to n that takes a std string Let's see what ChatGPT comes up with. Format to limited. Max size, yeah. Reserve. Oh, it uses back inserter. Reserve. Yeah, it's also this is weird. Can you write it without using std? back inserter. Yeah, so start pos, what is the start pos? Ah, output size. Huh? Ah, so you... Ah, okay, so you give it... Okay, that's not stupid, yeah. Yeah. Okay. Resize, yeah. And then resize, start pos, std min. What the hell? Okay, util. So format to limited args. Format string. Okay. Formats. Okay. Ensure the string has enough space to hold the new content. Yeah, start pos, std size. I think we can remove the std here. Keep it simple. So we have size t, max size, start pos. Okay, I think this makes sense. And then we resize it. Accommodate formatting, yeah. Let's we can remove this. Okay, so we resize this guy. Start pos. So if we want to write to fresh, is it even? Let's see. Max size. Start pos. My first guess would have been to just like assume that we always write to the beginning of the string. But I guess this approach makes it more versatile. But it also format to limit. I think this approach would be better for a function which would be like append to, right? Append format to. So this would be append format to, right? And if we would just format to, then this would be format to n, and there we would just say resize max size, right? And then output begin max size, and we resize to, the hell is this here? Max size static cast out. Oh, result out. What is this? Out. What is format N? What does this return? Auto. What the fuck? Format to N output IT. Okay. Format to N result. Out. Size. Total not truncated output size. Total not truncated. Total not truncated. So why don't we just why don't we just resize to result.size? Wouldn't that be sufficient? And then we can have an assert that max size, result size is smaller equal max size, right? Don't need all these comments. There we go. Pretty self-explanatory. And here we would simply do all this junk here. I think is useless. We just do plus result.size. Start pos plus this. There we go. And then a question here, output begin plus, yeah, okay, this makes sense. Yeah, this makes sense. Yeah. Output resize, start pos plus max size. Yeah, this is okay. Yeah. And we can also add an assert here. Yeah. Append format to, let's call this assign format to N. Append formats. Assign format. How about that? Append format, assign format. This looks very efficient to me. Let's move this above the append because this takes precedence. There we go. Efficiently assign format to to string, std string. Efficiently appends format. Okay. So output resize, max size, yeah. Yeah, we don't need to clear anything, just resize, yeah. Output resize, yeah. Append, yeah. Result.size. Hold on. This assert is wrong. I need to say this plus this. Makes sense. You can also say here output.size. Yeah, this seems to be correct to me. Yeah, okay, why did we do all this now? Do we want to use it here? Yeah, here. Yeah. Okay. So basically we didn't we have a buffer already somewhere here? Bytes buffer. Okay, how about we call this we just call it buff, yeah? Buff. And we do, yeah, just buff. Just buff. Okay. And then here we do buff.clear. I think that is fair. And then buff dot as util assign format buff max size. Let's go with, we can just put any number here. Yeah, let's go with ASM instruction max. Let's just put here like 1024. How about that? Just have a generous size. And then we put this here. Okay. Okay, so this should be now a much more efficient way of, yeah. Maybe instead of calling clear, we put a assert. No, we don't. We just clear the buff. Okay, this looks good to me. Then here, so if instruction is invalid, we do this and else. ASM printer. In function CPP, how about we add a to do here, FMT format, to do upgrades to util assign formats. Okay. Okay, so is runner, no, where are we? MGUI app, where is it? Yeah. Okay, so actually I wanted to look into ASM printer because I'm a bit confused by one thing. Where's it? Jesus. Here, this one. This here to me makes no sense. Why is this here and not inside this scope? Because if the instruction is invalid, then surely it's not a jump, right? So I think it needs to go here. Yeah. Okay, so here we now put also util assign formats, buff, actually it's not assign formats. We do buff actually we can here, let's do a buff dot reserve 1024. Yeah. And then here we do buff dot capacity. Okay. But somehow that doesn't work. What? What? Okay, and here we say buff dot assign buff dot assign instruction text. It is a bit bad because we need to process it and strip in place. But at least there's no allocation. I guess that's good. Buff strip quote. Strip quotes. Here, strip quotes. Put the quote here. Strip quote. Let's just call it quote. Okay. Okay, so at least there's no allocation here, at least as far as we are concerned. So that's good. And then we need to say if instruction is jumping, yeah, if instructions jump, then we append format here. Util append format, and we do plus. Why plus? I'm confused. It's jump. What if we do a negative jump? Huh? I think what it does is it puts a plus when it is positive and it puts a negative when the value is negative. I think. Yeah. Otherwise we wouldn't have written it like this. It's kind of obscure though. Okay, so put buff and buff dot capacity. Actually, capacity. We put capacity minus buff dot size. How about that? So it certainly does not allocate. Okay, somehow something's wrong here. Why not? What did we do wrong? Let's compile and see what's wrong. Okay, I got a bunch of errors here. FMT is unknown. Okay, so we need to actually include FMT core.h in here in the util. Well, that's fair, I guess. FMT. Yeah, let's see. Okay. Good. So compare. Okay, and let's click on here, and we still got the quotes in here. Okay, something is not right. Let's let's put a breakpoint in here. Let's see what this does. So buff, all right. Assign format 8B. Oh, right. So that's wrong. That is wrong. And now I just realized how inefficient the previous thing actually was. Because for every iteration, it would be one allocation. Oh boy. So this needs to be different. It actually needs to be an append format. We pass buff. We pass buff capacity minus buff size. And that's it. Okay, let's redo it. Okay, so both is clear, and 8b 542404 done. Okay, so this should be fast and efficient. And down here we have quotes, text, yeah, and okay, both is sign, yeah. So it just copies it. That's fine. And then both strip quotes is jump. Okay, let's put some more breakpoints here. So here we have no quotes. Let's hit something. Here we have a quote. Okay, so strip in place. So now it should strip the quotes from this, and it does. Okay, good. And then okay, and then down here we need to pass both in here. There we go. Okay, that's a fix. Okay, so we have no allocations here. This is copy. This is stripping in place. This is appending. So there's no allocations. It's all clean. That's good. Okay. So it should be, I mean, it's a lot of processing, but it should be pretty fast because yeah, it's like in play. Actually, we could make it even faster if we put it on the stack, this thing. Maybe because it makes management a bit more complicated. Yeah. But that would be the most efficient if it's just like on the stack and you just append it there, right? So the SCD, this is still not the most efficient that we can go here because this thing is on the heap. So it's not the most efficient. The best would be if it was on the stack. Yeah. Yeah, but I guess for now it's a good enough improvement. Yeah. It would be nice to have a stack string. Yeah. Stack style string where the stack is not backed by heap memory, but is backed by memory that is on like within the object, right? So it's not a pointer to some memory in the object, but just a buffer of chars, right? That would actually be the best. Yeah, but we don't have this. I don't think it makes sense to change our I'm not sure. Okay, so now it says here plus 30 bytes. plus 12 bytes. It removed the quote. Yeah. Okay. How about we don't append this thing here, but we make it an extra string. So put here we take this thing here and we put it here and we put the unindent here at the end. Put this here at the top. Indent like this. Assign, strip in place, text unformatted, both. And then here is jump. We do another, we do a imgui, same line, and then we do a buff, do a assign format, buff, capacity, size, buff capacity. We use plus bytes, jump len. Yeah, and then we put here text unformatted, and we do a imp scoped push, no, style color, and we put imgui call text and color we put mu, what is it, mu32, im call u something, I forgot, imgui misc. We have it somewhere here now. Here, imcall, here, there we go. So imcall, and we put like a gray, so RGBA, so 0x, I don't know, 88, 0x, 88, 88. Let's go 50%, 7F, right? 7F. Or 80. 80 is good. Yeah. 80 and then 0xff, and there we go. Style color, and we call it gray text. Yeah. And then we put this here. Okay. Okay. And this should now print in gray text the jump len behind the jump instruction, right? Let's see. Compare. Okay, so yeah, there we go. That looks good to me. The faintest of grays. Okay. Okay, that's nice. Yeah. Okay, cool. Then string buff. Yeah. Let's add a to do here. To do put on stack. I do actually wonder, the std string, does it have, it does have an allocator. Is there a std allocator? Std allocator stack buffer based STL allocator. Stack allocator. Fully conforming stack allocator. Consider some of the ramifications. Fully conforming stack allocator. You need to consider your allocation patterns. Firstly, when using a memory buffer on the stack, you need to consider what exactly it means. Simplest method, simply increment a stack pointer for allocations. You can use allocate a single container, right? If used correctly, but will not fail. Yeah, I understand. Increments, decrements, stack pointer, then you will get undefined behavior. Will cause undefined if the first allocates a single contiguous block from the stack, then allocates a second stack block, then deallocates the first block. It will happen every time the vector increases its capacity to a value that is still smaller than stack size. That's why you need to reserve the stack size in advance. What do you really want from a stack allocator? Simply use leave for allocation and fall back on another allocator if it runs out of space. This works fine for SC vector, which will always use, and the same for a string. Can be reserved. When SC vector needs a larger buffer, it will allocate a larger buffer, copy or move the elements into the smaller buffer, and then deallocate the smaller buffer. When the vector requests a larger buffer, the above stack allocator information will simply fall back to secondary allocator, which is SCDI. Okay, that's great. This is great. This works fine for vector, but you need to ask yourself what exactly and why is this going on this again. If you want a general purpose, you have to draw from a stack buffer. More complex project, a simple stack allocator, merely increments. Isn't he repeating himself here? Line storage, actual stack buffer, non-port types. Howard hints the buffer implementation doesn't explicitly make a check when you call deallocate. The pointer passed to its last block. Hence, I mean, we simply do nothing if the pointer passed in isn't a leaf ordered deallocation. This will enable you to use SCD vector. This will enable you SCD without reserving in advance, because the allocator will basically ignore the vector's attempt to deallocate the initial buffer. Okay, what is this here? Stack alloc h, stack alloc. Okay, so he also implemented the stack allocator. Okay, let's go once more here through the differences. User provided fixed size buffer as his initial source of memory and then falls back on a secondary allocator. Then it runs out. Okay, how is he using it? Stack allocator, stack int, type def int. What? Why is that int? Stack size. What? Attempt to reserve space for 4 elements. Stack size 4. Buffer. Allocator buffer. Allocator type buffer. Huh? Why is it not just using alloc a under the hood? Why do you have it? Why do we have it to do it like this? Can't I just use alloc a free a under the hood? I don't understand. Why so complicated? I don't understand this part. Why does it have to be like this? Did you pass it a pointer to something? To give it the freedom where you want the buffer to be? So you can control the lifetime. Ah, I see. So you can control the lifetime of this. But it's stack buffer. It's when the I would imagine if the vector goes out of scope, then it simply deallocates. Like, why do we need this? I don't understand. This seems to be more complicated than it needs to be. How's it implemented here? Deallocate. Okay, so this also placement new here. That is good. But I don't understand why it can't use alloc a in here. Stack allocator alloc a. Yeah. So here, let's see. Oh my gosh, it's so much. So stack allocator other. Stack pointers. So what does this contain? It contains begin and end stack pointer. What the hell is all this? Well, there's so much. What the hell? Alloc. Begin, end. Buffer. Alloc. Allocator time. Alloc. Alloc. Begin null pointer. So it can also be null. What is the structure? Okay. Oh my gosh. So this one only has one pointer here and some buff. Okay, this one is different because here we have a storage in here. This one is much better. I don't understand why he's passing here external buffer here. Why? Why this stack allocator in Charles? Do people like this approach? Let me see. I've got 18 stars. Oh. I mean it's not bad, but this part where you have to pass a, so basically the stack allocator is just a wrapper around another buffer that you have, right? That's what it does. It doesn't own the buffer. Shouldn't it be? Begin end stack pointer. Okay, so it does he write anything about this? This allocator uses a user-provided fixed-size buffer as an initial source and then falls back. Okay, but why? It would be nice if he explains why he chooses to do like this. Means to allocate the simplest methods, increment a stack pointer. For back, yeah. I do like this. This principle is good. Yeah. That can be reserved in advance. It's a larger buffer. It will allocate a larger buffer. Yeah, that's fine. Vector, crystal, blah, 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 blah. Okay. The buffer implementation doesn't explicitly make a check that when you call deallocate, the pointer passed in is the last block allocated. Hence, implementation will simply do nothing if the pointer passed in isn't a LIFO ordered deallocation. This will enable you to use an STD vector without reserving in advance, because the allocator will basically ignore the vector's attempt to deallocate the initial buffer. As to use an STD without reserving in advance. I still don't understand his reasoning for this external buffer. Why would you want to do this? Why? I do like this one better because here we have the storage right in here. Size of t, what is this? Size of t times n. Yeah. What is, let me see, align storage. Align storage, what is the second argument? Align, the alignment, okay. Yeah. Yeah, this to me looks, let's copy this guy here. This stack alloc.h. But he does have some comments about it, but Howard Hinnan is a well-known C++ guy. He's the author of Chrono, STD Chrono, so he knows what he's doing. And I don't know why I'm going in here. And he knows some C++. Yeah. Unassemblize source util stack alloc.h. Okay. Let's get the URL as well. Sourced from Howard Hinnan GitHub. Okay, so source util stack alloc.h. So my hope is that now we can say so we go to a comment types. Comment types, and here we put include util stack alloc, and then we add a new type here, a new alias, using stack string equals std string, and std string takes char traits allocator. So take char std string char std char traits char, and then we put the stack allocator. Hold on, what is it called? Stack alloc So this is stack, just class stack alloc. What is this here? Has type traits 0. 1. Okay, so stack alloc and then we use what does it take? Stack, it takes a size tn. So we need using std size t size, or take n, and then here comma n. Yeah. And that still doesn't work. Expected that. Why? What's the problem? std string, where is it? Huh? Ah. Hold on. Templates. Wait. Is that correct? Template. Yeah. Yeah, I think that's correct. Okay, so that would be the stack string. And then we can also create a w stack string for w char t. Okay. And then I think what we can also use the stack vector, right? Vector. So that would be a vector. By the way, does the stack alloc has a fallback to std alloc? It's very short. Doesn't seem like so. Yeah, if we have such a requirement, then we can probably add it, right? Yeah. And there's a case to make that sometimes it's good to have the ability to have a fallback. Like you know your rough size, but you want to still be able to grow above it, which would happen. So actually, hold on. So this implementation by this guy. Aha, he put here another thingy here, allocator. And when does he do it? I don't even know what this rebind is. What that is for. Specialization for void. Huh. I would like to have a mix of this one and the other one. So the problem I see with this one is that you have to pass a buffer. I think it's weird. I think the allocator should own the buffer for convenience. Like, what use is it to have like the buffer somewhere else? Why? Maybe to say, okay, we want to have multiple things, multiple allocators using this buffer. But is that healthy? If you put multiple allocators on a buffer, the allocators won't know each other and they will totally conflict. So I really don't understand what the motivation is behind an external buffer. So when this guy goes allocate operator new. Huh. Ah, okay. Actually, it does allocate here. Look at this. Uh-huh. So it does have a fallback here. But the allocator is not std allocator. It's just new, operator new. Uh-huh. Okay, but this is good enough for me, to be honest. This is good enough for me. Okay, maybe add here some parentheses. Yeah, I think this is fine. No need to be fancy. Can delete this guy. Oh, it does have a throw. Why throw? I don't know why this row is here. That's... why is it pink color? What is going on here with the coloring? I don't know why there's this row here. I don't know what this rebind thing is for. Mystery rebinds. Where's it used? It's not used. Maybe it's used by some... by the STL library. It doesn't have a... does have a max size. Okay, let's see if this guy works. If it works, then I guess it's good enough for now, but yeah, there's some question marks, maybe. Yeah, I do like that it has this internal storage. That's great. It does have a fallback to operator new. It can allocate. It can deallocate. So that's great. Yeah. Maybe it should also have it should not be movable, right? This thing. I guess I guess one argument for the external storage is that you can then copy the allocator. You can move it. I don't know. This one you cannot move because the storage is here. Is that a problem? So I think we also need to remove the move constructor. Maybe. So comment types. So we have stack vector. So stack vector is vector type name n, type name t, vector t, and stack alloc t and n. There we go. No, I need also allocate vector here. Include vector. There we go. Okay. Maybe make some spacing here because it's hard to read. Okay. Good. Let's see if that compiles to begin with. No. What is the error? Chart trade, stack alloc. Stack alloc is here. Template declaration, syntax error. What? But it's here. It's all there. Template. Size TN. I don't understand what's the problem here. Hold on. Here. Could it be that we need to use basic string? Basic string. Yeah. And here as well, basic string. Yeah, there we go. Okay, let's try this out. So now in imGUI app, so we don't use the SCD string, but we use the we use our new stack string and we put here 1024, boof. And now the hope would be that this guy is on the stack, purely on the stack. We have dot clear, capacity. Well, we still need to reserve it. We still need to reserve. Yeah. Oof. Okay, and then this guy, we need to have type name string and be able here to pass in the string type. And same here. Pass in string types, yeah. Okay, let's try this. Oh, hold on, there's an error here. Let's try again. Static asserts. Oof. Instant aligned storage with an extended alignment. What the hell is that? I've never seen that. The fuck is that? Okay, let's get this into a text notepad because it's so long. So static assert failed. You have instantiated SD aligned storage with an extended alignment. In other words, align is bigger than align of max align. Align is bigger than align of max align. Aha. The member type breaks binary compatibility. Okay. So I suspect we need to. So I suspect the problem is this here, 16. Or not. Instance len alignment with an extended alignment. In other words, align is bigger than align of max align t. What? Hold on. What is max align t? What the hell is that? Max align t. Yeah. I've never seen this. Max align t 16. Okay. So how about we put this in here? Would this satisfy that thing or? Yeah. Now we just got another error left. Strip in place. Aha. Strip in place. Yeah. Strip in place. Erase. Yeah. Okay, strip in place. We need to change that. Strip in place. Strip. Yeah. Okay, let's make copies of these guys. And we put templates, type name string, and string strip All right. There we go. There we go. Strip in place. Strip. Oof. Actually, I think if we go back to our stack allocator, I think move is actually okay. Yeah, I think move. Let's remove this one. We will see. If it crashes because of moving, then we will see it soon enough, I guess. Okay, so we have strip in place, the strip. So we put here a string, strip, there, string, strip in place. This one is just... Let's do a string and pos, and here we do string const. Oh shit. Const type name string value type. All right. Erase. Okay, strip in place, strip, string, blah, blah, blah. Okay. str, strip, str. Oh. Strip. Yeah. Yeah. Okay, so this actually would, no, this, yeah. This would allocate if it was std string. Okay, but this does not. It's just erasing. Yeah. Okay. Then let's comment these guys out because we have pretty much deprecated them. So comment these. Okay. Okay. So efficiently strip characters in place. All right. Good. Yeah, let's see if that compiles. Yeah, it does. Okay, that's good. Okay, so imgui app. Yeah, this will be interesting now. So we have our buff. Let's call it stack buff. Well, let's call it stack string. Stack string. Okay. Let's remove the to do here. All right. Okay. So stack string is reserved. We cleared here. Has a capacity and a size, and the allocation should be entirely on the stack. And we just use it as we use the std string. Yeah. Okay. So then let's put a breakpoint here. Let's put a breakpoint here and here. And And stack string. Let's put one here as well. Okay, let's see what happens. Hopefully it runs. Okay, if it works, then yeah, we certainly should use the stack string for various other intensive string operations as well. Especially in the disassembly step, I think there's a lot of string stuff. Okay, so stack string has a capacity here. Allocator is boof. Boof. Pointer, okay. So let's see what happens if we go into reserve. We can't step into it, okay. So it has capacity, but the capacity, oh, it's bigger. It's, okay, that's bad. The capacity is bigger than what we have asked for. So this has allocated now, basically. Right? Yeah. That's not good. Yeah. So it looks like std string does something strange on reserve. Capacity. Capacity. Why can't we go into this code? We can. Just took a long time. Okay. Reserve. Reserve. New cap. Grow by. New minimum length. The new minimum. It would be nice to say like, hey, I really want this to be my max reserve, not my min reserve. Reallocate, grow by. What does it say? Oof. Oh my gosh. Unfancy. Calculate growth. New size, old size, plus size increase. Oh. Oh. Now that is weird. That is extremely weird. So it grows not by it doesn't grow to 1024, but it grows to current reserve plus this. Now that is weird. Okay, so let's say I want to grow to 1500 afterwards. What happens? Let me see. That is so weird. I never really looked into this growing pattern of string, but that's weird. I have to say that's absolutely strange. Okay, so it starts with a capacity of 15. Because of small string. The small string has a capacity of 15 by default in MSVC. And then Now it's 1024 plus 15. No, that's weird, man. And what now? Now it's 1558. What the hell? How did he come up with this value now? No, that is weird. That's absolutely. That's weird. I don't understand why this allocation pattern is so strange. I request 1500 and he gives me 1558. Why? Why so much more? Well, phew. That's weird. That's weird. Okay, I guess what we can do is we just under allocate it with the 1000, and then that's probably good enough then. But yeah, that's not so nice. Yeah. It's not so nice. So now we have 15, and now we have 1007. Now I don't know why it's 1007. Can we go back to X string? Reserve. I really would like to step into this code, but somehow the debugger won't allow us. Debug, options, debugging. I think it's this one here. Oh, got a crash. Oh, stack alloc. Operator delete, look at that. Ha. Ha. Well, no, that's not good. Okay, so a stack allocator does not work. Yeah. Okay. How about we pause this stack allocator investigation for now and revisit it another time, because this is a bit more tricky. Yeah. Then let's put it back to std string. We reserve it to 1024, which really is then 1000 bigger. We call it str or buff Let's call it buff again. Okay. To do stack allocation. Make stack allocation. Okay, good. Yeah, for now we don't need this, but it would be nice to have, certainly. Okay, let's remove these guys. All right, so yeah, the texts are here. Everything is okay. Now, what's the time right now? Oh, we're already over 2 hours. Maybe we should take a break now. And then next session, we try to figure out how to... We should probably move these guys here into smaller functions to begin with. This one and this one here. We move it into small function. By the way, this one we can delete. Yeah. So we move this into a smaller function, and then we try to figure out how we can reuse this code here to also use it for the other column, for this one, where we need it the same way, but the columns need to be rearranged differently in a different order here. Yeah. Okay, so this we'll do next session. And then later we can still figure out what we do with the stack strings. But yeah, it would be nice to get some more things onto the stack when it's really not necessary to have it on the heap, and especially not allocating every time. So right now what we do here in function CPP, this is highly inefficient. Actually, yeah, it is, because the symbol name is likely longer than 15 characters. And then it won't fit into the small string, into the small string. So inside this object, it won't fit in there. So it will be an allocation here. Very likely. Sometimes it may be shorter and then it's fast, but most of the time I expect every time this is an allocation, and there are probably a lot of allocations, and it's probably one of the reasons why the disassembler is so slow. Yeah, I think so. It's, I mean, there are probably other reasons as well, but the allocation probably makes it very slow, and if we fix this, it probably becomes quite a bit faster. Yeah. Good. I don't have evidence to show, but it's just experience. Like, avoiding allocations is typically very good. Yeah. All right. Yeah, let's take a break here and continue with the table in the next session. And yeah, I wish you a great day or night until next time. Goodbye.